Honey, I handed this out a long time ago. A long time ago. Yep, nope, I didn't just hand it out. I handed these packets out a long time ago because I wasn't sure if we were going to be on the retreat or what the heck would be going on. So they're pretty small. And the very first page has a bunch of typing stuff on it. Right? The very first page has 3 little quizzes on it. And oh my gosh, there are 3 little quizzes that we are going to practice right now. What do you think might happen on Monday? We might have one. So I would suggest you listen carefully and engage. I'm looking at the first quiz. The equation, r equals 7 cosine 2 theta, is a rose. How many leaves does it have?
2.
I'm at the top equation. 4. It has 4 leaves. Why does it have 4 leaves? Because we learned by observation the other day that when we have an even coefficient on theta, there's twice that many leaves. But when there's an odd coefficient, we have that number of leaves. How long is each leaf in the question above? 7 units long. A figure 8 is also called a lemniscate. Now you can think lemniscate, figure 8, but when we say it, it is pronounced lemniscate. But that is your figure 8, a lemniscate. The origin in polar coordinates, the origin is called the pole. P-O-L-E, the pole. All right, let's go down to the next quiz.
You said the coefficient's odd, you double it?
No.
No, if it's even, you double it. If it's odd,
Burkhart, where's your notes? We did about 50 of those.
Wait, we're talking about the coefficient when it's the theta, right?
In front of the theta.
No, I was looking at the coefficient in front of the cosine the whole time.
Okay, the coefficient in front of the cosine is the length of the leaves. It has nothing to do with how many there are. All right. Number 1 on the second quiz down. Is r equals 8 minus 8 cosine a cardioid? Yes. Why? Because 8 and negative 8 have the same absolute value. Now, here comes the next thing we have to talk about. So I'm going to hold off on number 2. It is the one vocabulary word we didn't get to, and we didn't graph it yet. So I want to, actually, number 2 we did. Because when we graphed this the other day, we graphed one spiral, right? Remember that?
Yeah.
Went round and around and around. And it started, if you recall, it started at the pole and spun out and did this, right? And it went around however many times we told it to go around, and then it stopped. That kind of spiral that starts at the pole and spins out is called an Archimedean spiral, or a spiral of Archimedes. Archimedes was one of the great Greek mathematicians. So this is called an Archimedean spiral, or a spiral of Archimedes.
They go either way.
Huh?
They go either way.
It starts at the pole and spins out. That's what it does. Now we're going to look at, we haven't graphed yet one that goes the other way around. We're talking about a spiral that starts at the pole and spins out. Anybody remember the equation of the one we graphed the other day? R equals 2 theta. R equals something theta is an Archimedean spiral. So R equals 3 theta, R equals 1/2 theta. All those would be Archimedean spirals. How many leaves does R equals 3 sine 4 theta have? 8. In converting from rectangular to polar, okay, so stop. In converting from rectangular to polar, so I have x and y. I have x and y. How do we find r? Pythagorean theorem. So r is going to be the square root of x squared plus y squared, right? Every time? That's how we find r. Good. Last quiz. Draw a simple freehand sketch of a lemniscate. What are you going to draw on your paper? You're going to draw any kind of figure 8. So you can draw it diagonal if you want. You can draw it up and down if you want. You can draw it sideways if you want. It doesn't matter. Those are all examples of lemniscates. How many leaves does this thing have? 3. Now, number 3 on this quiz is the one we have to wait on because we haven't talked about a spiral that starts out and spins in. We're going to graph one of those in a minute. So leave that one blank for a second. A cardioid is a special kind of limacon. Limacon. A cardioid is a special kind of limacon. All right, turn the page over. Turn the page over. It should be in your notes, Michael. Or the next quiz. This is a polar conversion quiz. We've talked about all these things already. What equals r cosine theta? X. Is it important for us to know that x equals r cosine theta? Yeah. Yeah. X equals r cosine theta. What does r squared equal? X squared plus y squared? And what does tangent equal? Same thing it's always equal. Y over x. Y over x. It also does equal sine over cosine, but in terms of conversions, we need y and x. Y over x. All right, looking at the quiz at the bottom, we're going to do number 1 and number 4 today. We'll learn how to do those. But right now, we're looking at number 2. How many leaves does this equation have? 8. Change 4 100 into rectangular coordinates. Okay, now wait a minute. So 4 100 is r and theta, right? And we want to change that into x and...
So put x equals r.
Exactly, Brenton. X equals r cosine theta and y equals r sine theta. This is all review. These are things we've talked about before. Okay, so what do we need to do? Well, we need our calculator. 100 degrees is not an angle that we are familiar with. So make sure you're in degrees. And I am getting negative 0.69 and 3.94. Okay, Max?
When do we know when we have to change from the mode in radians to degrees? Like what sort of problem?
That's 100 degrees. So obviously we need to be in degrees. Okay, now the last things are the things we have to talk about today, which are question 1 and question 4 on this quiz, which we're going to get to. But first I got to go back, we got to deal with that other spiral. So we've already talked about the Archimedean spiral. That's good. Now we got to talk about this other kind of spiral. So let's put our calculators into radians again. I like to do spirals and radians because revolutions are so much smaller. So I'm still in polar, still gotta be in polar mode. Calculators and radians, right? All right, now I'm gonna go to my window. And normally, when I am in radians, I go theta min and max, I go 0 to 2 pi. Now, why do I not want to do that if I'm going to graph a spiral? What happens if I go 0 to 2 pi in a spiral? I only see it go around one time, right? And that's not a spiral, that's not fun. So I want it to go around 10 times. So I'm going to go 0 to 20 pi. Now, what about our step if we're in radians? 0.1 is a good choice. What?
I heard Precal stops for nothing. Turn the lights out. Got no windows in here.
Doesn't matter who needs it. We had our calculators and our phones and our flashlights, and we had everything we needed.
So, like, why did the power go out? Like,
Somewhere there was a power outage.
Why didn't it stay out?
Have you eventually gone home?
we were 5 minutes in.
Oh, we were not.
So Mr. Davis.
He is just trying to give you false hope.
Really bad.
All right, so I just had to play with mine for a minute to make sure I was going to have a good window. So, oh, really tells that graphing. All right, so you went from 0 to 20 pi, right? All right, you set your step at 0.1. All right, now I want you to set your mins and maxes for x and y at negative 0.1, that is negative 0.1 and positive 0.1.
What is their scale? 0.1?
It can be 1. Doesn't really matter.
Wait, what's the scale be?
It can be just negative 1. All right, so your min and max on your x and y are at negative 0.1 and positive 0.1, right? Okay, now the equation I want you to graph is r equals 2 over theta. R equals 2 divided by theta. 2 divided by theta. And then I want you to watch what happens. R equals 2 divided by theta. Now at first nothing happens, and then what happens all of a sudden? What happens? It starts coming in, right? And what is it doing? It's spinning around and around, but it came from out here, and it's spinning in around the pole, right?
Yep.
That's different than what happened the other day. What happened the other day started at the pole and spun out. This spiral, which starts out and spins in, is called hyperbolic. It is a hyperbolic spiral. Now, there are zillions of different spiral shapes you can graph. You remember, kids, the equation I just gave you was 2 divided by theta. The one we graphed the other day was 2 times theta. What makes something a spiral? In the equation, what is missing? The cosine of the sine, the function, the trig function. Trig functions are periodic. That means they repeat themselves. So when you put a sine into the problem, let's say it's a lemniscate, it'll graph forever, but it just keeps graphing over top of itself when you put a sine or a cosine in the problem. When you don't put a sine or a cosine in the problem, then every r value is different, and it just keeps producing new r's. Well, depending on the setup of the equation, the r's will either get bigger and bigger, or the r's will get smaller and smaller. You can put together, you can make up your own equations that have no sines and cosines in them, and you will see this spirally type thing. One of the classic ones is the hurricane symbol. Have you seen it? Something like this, where it's like two spirals put together, spinning in from opposite sides. You can create that equation, play around with it a little bit. You can come up with that shape. So, the two basic types of spirals. Archimedean, which start out and spin in. Archimedean, which start in and spin out. And hyperbolic, which start out and spin in. Alright, so that takes care of all of the front page. Now on the second page, we have, at the bottom, we have this number 1 and number 4 to talk about. I didn't tell you this before because I didn't want to overexcite you, but I think it's time now that you start getting really, really enthused about why we're even doing this. It's cool, the pictures are cool, but here's why we're doing this. Have you ever thought about trying to find the cube roots of -1 plus 2i? No. Well, think about it now. This is an exciting thing because you are going to find the cube roots of imaginary numbers. What? I know. And not only are we going to find them, but we're going to graph them. So it's going to be really exciting. But here's the first step. First, we have to deal with numbers in what are called complex form. This number is said to be in complex form, Cartesian form, or rectangular form. This is the equivalent of an x -1 and a y of 2. If I graphed this, it would be left 1 and up 2. It would look exactly the same as the point, or I should say it would be in exactly the same place as the point -1, 2. The difference is, this is not a point. This is an actual number. It's a complex number. Remember studying those and all that I stuff? You're now going to do stuff with numbers like that. Not just add them and stuff, but taking the powers and stuff like that. So, first thing I need to do is take this number that is now in rectangular form, and I need to change it to what is called the trigonometric or the polar form. So I am going to convert this number to the trigonometric or polar form. Now, believe it or not, that is incredibly simple. I am starting with x plus yi. X plus yi. What do we know about x? What does x equal?
R cosine theta.
So I'm going to say that's r cosine theta plus r sine theta I. Would that be okay? That would be fine. Typically, the r is factored out, and it's written like this. That is called the trigonometric or the polar form. It's as simple as that. So, here's my number, -1, 2. What's my r? 2i. What's my my theta. Now it's going to be here. This is going to be my theta, just like before. How am I going to find that? Tangent, inverse tangent. No, I need opposite over adjacent, so it'll be 2. Whoop, I'm in radians. Let me change it back to degrees. I got 63.4.
So then do that minus 180,
So the actual theta would be 116.6. Now, yesterday, when we did this problem, it didn't look like this, it looked like this. And we changed it into root 5, comma, 116.6. Remember that? We're doing the same math, the same picture, the same calculator stuff, everything's the same. The difference is, because this original number was a number and not a point, it wasn't an ordered pair. When we convert it, it looks like this. It's the same root 5 and the same 116, it's just written like this. Because you have to have the I in there. Because it was in the original problem. Now this gets a little tedious writing this out, so there is a shorthand for that. You are allowed at any time, and I will always use the shorthand. This is the shorthand notation. That's a CIS. Anybody want to guess what the CIS stands for?
Cosine imaginary sine.
That's it, cosine I sine. So we just take that out, abbreviate it CIS, and we know our radius is root 5, and our angle is 116.6.
There's a button on the catalyst.
Now, let's look at number 1 on this bottom quiz that we haven't done yet. Problem number 1 is exactly what we just did. The number is 2 minus 3i, and we are changing it into polar form. Now, polar form is the same as trigonometric form. Those two words get used interchangeably. And what did Mrs. Ford tell you polar form was? R, well, longhand, or you can just do R, CIS, theta. So we are looking for R and theta. And what do we know? X is 2 and Y is -3. So what will R be? Root 13. And then theta I'll have to figure out. I got 56.3 for this guy. So what theta do I want to use? What's theta?
It's a 3 of 3.6.7.
Yep. There it is.
Was that the answer?
That's the answer. That is the polar form, or the trigonometric form of the number. All right. Now, let's do one more of those just to make sure you've all got it. And then we'll talk about how to multiply them and divide them and stuff like that. We're gonna get around to our goal. We're gonna get around to finding those cube roots in a minute, but we're not ready quite yet. So let's change, we're in section 6.5. Let's change -3 minus 4i into, actually this could also be 6.6. I'm not sure which section this is in the trigonometric form, which is also called polar form. Now, when you see this trigonometric form, into your head should pop RCIS theta. That's what I'm going. It's where I'm going. Mallory, doesn't do you any good to sit in the front if you're looking the wrong direction and have your eyes shut.
So R is 5.
So, R is 5. -3, -4, R is 5. Right?
Right.
And then what? Well, we need to find that angle so we can do our tangent thing. Can't we?
Yes.
Second tangent, 4/3. That's about 53.1.
Yeah, 270 minus 180 plus 188.
270 is not at all even involved with that angle. So it's going to be plus 180. So it's 5 CIS 233.1.
Okay.
Okay? Now, everything I've talked to up to this point, right here, is fair game for a quiz on Monday. Okay? So what have I said today that you have a question about? Because I've got a few other things I'm going to talk about that won't be on the quiz. But everything up to here is. So we did all that review stuff at the beginning, all those old quizzes. We distinguished between the hyperbolic and the Archimedean spirals. And we talked about what it means to be in trigonometric form, polar form.
How do you, is the only way to know if it's Archimedean or hyperbolic is by graphing it?
Mm-hmm. No, the equation will tell you.
If it's like
Is
divided
it-
by theta, it's
Yeah.
hyperbolic. Okay.
Work hard. Think about that for a minute.
I already did.
No, you didn't. If the spiral is spinning in,
Yeah.
that means the R values are getting smaller. So as theta gets bigger, 2 over theta is going to get smaller. In an Archimedean situation, as theta gets bigger, 2 theta is going to get even bigger. So it's going to spin out, right?
When you got 53.1, do you have to use tangents?
No, you can use anything you want.
Then
Now-
everything would work?
Well, yeah, but we always use tangent, generally speaking, because what are we always given? X and Y. But you can use any function you want once you know what R is. Okay. All right, so here's the next thing. Let's suppose that I have 2 complex numbers. And to be like your book, to use the same notation as your book, I'm going to call them Z sub 1 and Z sub 2. And these 2 numbers are 3 CIS 100 and 6 CIS 20. Now, we're going to have a need to be able to multiply complex numbers. So I'm going to show you what the answer is, and then I want you to tell me what I did. If these are my two complex numbers in polar form, this is trigonometric form, polar form. If I were to multiply them together, my answer will be that. Now, what did I do? I multiplied the R values, and I added the theta values. So if I had a third number, let's say 10 CIS, I don't know, 45, and I said, what's Z sub 2 times Z sub 3? 60 CIS 65. Everybody got it?
You're dividing like Z1 or
Okay, now wait, I'm not there yet.
Alright, I don't know if we can go.
Burkhart, don't sell me short.
Sorry.
Alright, so how do we multiply numbers in polar form? We multiply the R's and add the angles. Now, I want you to think about this for a minute. Why in the world, Mrs. Ford, would I ever want to do this? Well, think back to like second year algebra, where you had to multiply -3 minus 4i. That's a complex number, but it's in Cartesian form. And you had to multiply it by another number. What did you have to do?
Cancel it, get rid of that imaginary number thing.
You had to FOIL it. Right? If you wanted to multiply those together, you FOILed them. And in the process of foiling, you get an I squared, which is -1. And you, okay. The point is, this is so much easier. Because if I want to multiply these two numbers, there's no foiling involved. There's no simplifying involved. It's 18 CIS 120. Now, you're thinking to yourself, well, Mrs. Ford, come on. That really isn't that big of a deal. All right, so let's do this. Uh-oh. Now it is a big deal because that's going to take you forever. But look at this. If I want to find Z sub 1 cubed, if I want to cube this number, all I have to do is think about it. It means this times itself 3 times. So won't it be 27 CIS 300? Because all I do is multiply the 3 times the 3 times the 3, and then add the 100 and the 100 and the 100. So you just cubed that number, and it took you about 2 seconds. And if I were cubing this number, I'd still be working on it 5 minutes from now. What about, let's practice one more. What's Z sub 2 to the 4th? Could you figure that out? Oh, that's kind of a big number, but I think you can figure out. What would that be? Z sub 2 to the 4th power. Might be the calculator. One, two, so it's going to be 1,296 CIS what? 80. Where did the 1296 come from?
6.
6 times 6 times 6 times 6. Where did the 80 come from? 20 plus 20 plus 20 plus 20. What you are using is one of the most awesome theorems in mathematics. It's called de Moivre's theorem. And de Moivre's theorem says that if you want to raise a number in polar form to a power, all you have to do is what? You've done 2 of them. Tell me, what did you do? How did you get this 1296? What did you do? So, yes, it involves a multiplication and addition. So how did you get to 1296? Multiplied the R this many times. So it was basically R to the n. Right? And then how did you get the 80?
This is times.
It's n times theta. That's right. It's theta added up n times, but that's the same as n times theta. So now we can do that last quiz question. What is 3 CIS 50 to the third power?
27.
27 CIS 150. You just cubed this number, and it literally took you 5 seconds. Well, we're going to come back to that. But first I got to get to Burkhardt's question, which is, okay, when I multiply these guys, I multiply the R's and add the angles. What if I want to divide them? Any guesses as to what I would get if I divided these two numbers? How I would do that? Work hard.
So when you divide, you put 3 over 6.
Yep.
And then you do 100 minus 1.
Yep. So it would be 1/2 CIS 80. When you divide numbers in polar form, you divide the R's and subtract the angles. Now there is one potential hitch. Let's suppose we were doing z sub 2 divided by z sub 3. All right, z sub 2 divided by z sub 3. Okay, so that would be 3/5 CIS negative 25. Now, that's the glitch, because whoever made up the rules about trigonometric form or polar form decided that theta has to be between, oh, by the way, that number is called the argument. The argument has to be between 0 and 360.
So should we find the coterminal?
Oh, so should we find the coterminal angle for negative 25? Yes, you should. And how do you find a coterminal angle?
36 plus 360.
Yeah, 360. So the actual final answer is 3/5 CIS 335. Does 335 get plotted in the same place as negative 25? Yes. There is nothing wrong with the negative 25 except the rules say it has to be positive. So we just change it. All right, here we go. Is that little bar over the top? That's the notation for conjugate. Now, if this were a rectangular number, like 2 plus 3i, absolutely everybody in the room would be able to tell me what conjugate is. What's conjugate? 2 minus 3i?
Yeah.
People, that's like a long time ago stuff. I mean, other years stuff. Okay? Now, let's look at these graphics. Over 2 up 3 looks like that. over 2 down 3 looks like this. What can you tell me about this R and this R? They're the same. So the R for the conjugates is going to be the same. So whatever this conjugate is, its R is going to be 3. Does that make sense to you? Now, what can you tell me about this angle and this angle? They're the same, except for the conjugate, it is negative. So if this angle is 10, this angle would be negative 10. So this guy will be 3 CIS negative 100. Because when you do the conjugate, R stays the same, but instead of having a positive theta, you're going to have a negative theta. Now,
you gotta change this.
Gotta change that. That's always gonna come out negative, but it can't stay negative. So what's your final answer gonna be? 260. So the conjugate will be 3 CIS 260. All right, one more thing. Now remember, none of this that we're talking about is on your quiz. What do you think it means? Here's the number that we started with. Any idea what that means?
That's the value.
The magnitude.
The magnitude of the number. It means if you drew a picture of it, how long would it be? Would it be 3?
Hey.
The guy who never comes to class knows the answer. It is 3. Why is it 3? Because what does that tell you? R is 3. And R is the magnitude. R is the magnitude.
I told you, I watched the video.
Tomorrow, or Monday, we have a quiz. Would you turn that off?